Okay, we're going to start with a warm-up. Anytime through here, since we're using the calculator a lot today, if you need more time to put the stuff in your calculator, please just pause it and then catch back up and then play it again, because I'm not going to wait while you're putting everything in there. So the warm-up says fill in the circle with the inequality that would result in the graph. So we know that this graph is shaded below and is definitely a solid line. And then the other line is shaded above. Okay, so that's one thing that we know. So the one that is going straight horizontal, this guy right here, that has to be the one that doesn't have an x in it, because it's not touching your x-axis at all. So this equation of this line must be that one, because it's at -1 on the y-axis. So since it's shaded below, then we're going to put a less than or equal to. And the equal to, of course, is because it's a solid line. Then the other one would be the one with the slope. This one fits that equation. And I would probably solve that and go ahead and move this x over to the other side. So you would subtract x from both sides. And you would have y in whatever your circle is. And then you would have -x minus 2. That way you can actually see which way to point your arrow. In this case it wouldn't have mattered, but you know that it's shaded above, so it's greater than or equal to. Okay? Alright, let's get started with our graphing with technology. When we did the best fit line yesterday, we had to do it all by hand, and everybody's was probably different because we could have picked 2 different points. So like on your homework last night, if you checked it with somebody else, then you might notice that your answer is not necessarily the same one as they got, because you might have chose 2 different points. So the best way to construct a best fit line is to use a calculator to do it, or a computer program. And I've got my little calculator here. I can't really use this calculator, it's just going to be a visual for me so that I can show you what we're talking about. When you draw the best fit line by hand, it's okay if your line's slightly different from someone else's, like I had mentioned. As long as both of you follow the same trend of your data, the calculator computes the equation of the best fit line using the method called linear regression. Linear regression just means that you're going to look at that regression line and get one that's best fit. So in your calculator, go ahead and turn it on, and for those of you who don't have one yet, I really suggest that you get one before the next test, which will be on Tuesday, not today, but next Tuesday. And what you're going to do is you're going to hit second and data. So second is up here in the corner. It's the one that's a different color button. And then data is going to be right there, right above, it's 3 above the 8. Okay, so data is right here, and your second button is right there. So you want to hit second data, and this is going to put the calculator into stats mode. And this right here actually tells you exactly what you need to do, step by step in there. You want to select 2 variables, so in order to do that, you're going to have to hit the arrow over. So you're going to have to over arrow. And you're going to do that until it says 2 var is underlined. You want to make sure 2 var, because you have 2 variables in there. You have an x and you have a y. All right, and then next you're going to hit second data again. So second data. And then you're going to scroll over until it says clear data. So once clear data is underlined, you have to hit enter. So that's not actually on here, so I'm going to write it. You have to hit enter. If you don't hit enter and you just clear out of it, then it's not actually clearing your data. If someone else is going to be using your calculator, then you want to make sure that you clear your data each time, because their data will still be in there and you might type over it. All right, so then step 3, you're going to hit data one last time. And since you're not doing second data, this is actually going to put you into where you can actually put in the x and y coordinates. And you're going to put them in as ordered pairs, x1 and then y1. And you use your down arrow to move from x1 to y1. So you would enter your data point as x1, and then you would hit the down arrow, and you would enter your data point as y1. So let's see how that works, and I'll come back to number 4 when we get there. So let's look at example 1. And now that you're in there and it says X1 and it's kind of blinking right there next to it, put in a 1 and then hit the down arrow and put in 722. And then you would hit the down arrow again and it says X2. So then you're going to put in 2 and then down arrow again and you put 763. And then you're going to down arrow again and it says X3, so you put in 3. And you just keep putting the down arrow each time that you put in a number. Now if yours says frequency, then you need to go back and put it in the 2 variable. You do not have it in a 2 variable if it says frequency after you push the down arrow. Okay, so make sure that you have already done that. And this is good to roll through this every single time. Once you put your calculator in your stat mode, you shouldn't have to redo it, but sometimes you do. Okay, so you can pause the video and go ahead and put all that in the calculator. And then when you start it back, I'll be ready. So now that you've got everything in your calculator, we're going to go back to this step 4. Everything's in there. You're probably on the one that was, this would be X7 and this would be Y7. So if you hit down arrow again, you would have X8 and it's going to be blank and you don't need to put anything in there. So with it still sitting there, you're going to hit stat var. Stat var is right next to the data button. Okay, so your stat bar is going to actually calculate your stats for that set of data. And when you hit stat bar, you're going to go all the way to the end and you're looking for A, which is your slope, and then B, which is your y-intercept. Okay, so scroll all the way over until you see A, B, and then write those down. So you're going to write down that you found that A was 27 in this case, and B was 699.43. Okay, and I like 2 decimal points. So then you can write your equation. It says approximate the equation for the best fit line using the calculator. That's what we just did. So y equals 27x plus 699.43. Okay, so that's your actual one. Use your equation to predict the attendance for the 10th football game. So it says that the football games are my x's. So if I want to know the 10th football game, then I would plug in 10 for x. So if x equals 10, then you can go back and say y equals 27x plus 699.43, and I'm going to plug in this 10 right here. So y equals 27 times 10 plus 699.43, and you're going to get y equals 969.43. Okay, I can't have 0.43 of a person, and it says predict the attendance. So since it says attendance, I know that it's talking about people. So we're just going to estimate this to be 969 people. So that's how many it would be. You can't round up because you can't create a portion of a person. Okay. All right, example 2. It says use a calculator to find the equation of the best fit line for the data to the right. So it's talking about the academic year and their cost. And it wants to know the correlation coefficient. That's R when you look in your calculator. So you're going to do the same thing. But when you're putting this in your calculator, it's going to be years since 2000. So in other words, your X value is not going to be 2000. If it's between 2000 and 2001, then you're starting with year 1, and then year 2, and then year 3, and so on. Okay, so in 2007, you would plug in a 7. So when you put in your data, these are your X's and these are your Y's. So take a minute and go ahead, pause, and put all your data in there. Remember, you're going to make sure you're in two variables, which you should be because you just did that last one. And then you're going to do second data, clear all your data because you want to clear out everything that's in there. And then you've got to hit data, and then that's when you scroll through using your down arrow. All right, once you hit stat var, after you get everything in there, you're going to look for not only your A and your B, but you're going to look for your R as well. Your R is your correlation coefficient. So R is 0.996. It says to 3 decimal places, so that's the reason why I did 3 there. That is considered, since it's really close to 1, basically rounds to 1, that's a strong positive correlation. Okay, so strong positive correlation is what I would say that is, because it is a positive number. It's very close to 1. So it says predict the cost of attending in 2012 to 13 academic year. Well, as we noticed in all the other ones, we use that last number as our x values. So that's why I know that this one's going to be 13. So x is going to equal 13 on this one. And you've got to know your A and your B in order to write the equation. So I'm just going to go ahead and write the equation because I know my A is 409.43. So that's my slope times x plus 3001. Okay, so then I'm going to plug in 13. And when I put it in my calculator, I get that it's going to be, and I know it's money because it says the cost, so it's $8,323.59. So that's how much it would cost to attend that particular school. It says academic year, so it's got to be a school, probably college. That's how much it would cost to attend in 2003. Okay, so I want you to pause the video, try this one on your own, and then when you restart, I'll be ready to go over it with you. So it says the table gives the average class score Y on each chapter test after the first 6 chapters, X of the textbook. So this is your test, it's your X, and this is your average class score. Okay, so this is your chapter test is what that's talking about. Okay, so there again, you're going to put all this into the calculator. So if you need to, well, you already tried it on your own, so you don't need to pause it right now. But you should have gotten y equals 1.26x plus 81.93. Now, I know y'all are loving putting this in the calculator because the way that we did it yesterday was so long, took us forever. And this way, we're all getting the exact same answer. Our correlation coefficient was that R that you look for also. And so I got 0.91, and that would still be considered a strong positive. It says use your equation to predict the average score on Chapter 9 test. So since the test is my x, I know that x equals 9 on this equation. So I'm just going to plug it in. Y equals 1.26 times 9 plus 81.93. Calculate that. And you get 93.27. Okay? So it would basically, like in the grade book, if I saw that, then I would say it was a 93. Okay? Because it says predict the average score. All right, residual plots. Residual plots is a graph. So residual plots goes here. Residual plot is a graph that shows the residuals on a vertical axis. So in other words, the vertical axis going up and down is what it's going to be showing my values on as the independent variable on the horizontal axis. So on the horizontal axis, that's going to be something different. So if the points of the residual plot are randomly dispersed around the horizontal axis, you're looking all around the horizontal, then the linear regression model is a good fit. Okay, Okay, that's what we call it. It's a good fit. If it's randomly, if it's kind of the same on the top and on the bottom, then it's a good fit. Otherwise, a nonlinear model is more appropriate. Okay? All right, so you want your distance from the residual points on the plot to be close to the x-axis. So we want them to be as close to the x-axis as possible, rotating back and forth between the top and the bottom. It doesn't have to be exactly like one up, one down, one up, one down, but it does need to have about the same amount above as a below. So then there's different types of equations, not linear maybe, that would be a better fit for this model as opposed to a linear line. So in other words, maybe it might be exponential or something. So if we look at these and we see this first one, we can tell that it's kind of dispersed pretty evenly. And if you look at your scale on the side, it only goes from 3 to -3. So that's actually pretty close to the x-axis. So we want to see how close they are to this and if they're about the same above as there are below. And I would say yes. They're pretty randomized, same number as above and same number as below. So this is a good fit. Okay, so we look at the next one. And we can see that if you counted them, there would probably be about the same number above as below, but it looks like it creates a pattern. So they're not necessarily randomly dispersed. So I would say that this is not a good fit. And that's what we're going to do with each one. We're going to say whether it's a good fit or not a good fit. So this means that it's probably an exponential, so a nonlinear. A nonlinear model would work better for that. A linear regression does not work well for that data set. Okay, so then we move over to the next one and we can see that there's still, it goes from 3 to 3, so they're still pretty close to it. And it does make a pattern, but it's not as much of a pattern as like there's some above that aren't below, and each one is like there's some here, and then there's some here and here, and they're all over the place. Okay, so that's pretty randomized, so I would say good fit. Okay, and then the last one, obviously, this one, since it makes that pattern, even though it looks like it makes a line, that doesn't necessarily mean that a linear one would work, because we're looking for something that is randomized above and below. So this one's not a good fit. Okay, and I'm going to put all of these videos that I'm doing this week on my website. So if you need to, you can go back and look at these, 2 or 3 times at night if you don't understand your homework. Miss Vance and Miss Brown and Miss Benson are all available for tutoring, so there's really no reason why anybody should get confused about this stuff. You can just ask one of them and they'll be able to help you.